So what we're going to cover with this is we're going to go through how to set up the dev environment. We're not going to show how to set up the dev environment. We've covered that before. But we're going to show how to use the dev environment to run a test web server and then add simulated events to it. So we'll walk through the whole process. And the screen has a lot going on because usually when I'm in dev mode, I do a lot of stuff against the same machine. So what I have, everything I'm doing, I use a Windows-based operating system, and I'm using VirtualBox to run a VM. And in this case, so I have my VM system running. This is my builder. So this is the actual VM. I never actually log into the VirtualBox window for it. So I have a whole bunch of SSH sessions. Every one of these, even though they're different colors, is logged into the build VM. Right, so I do that because I do different. SSH'd into the build VM. And I do different colors because I do different things in different windows. And so when I go to, when I'm actually looking for my windows, it's not letting me do it. Right? It would actually show me the different panels, and I can tell by color which one I want to jump to. So it's really handy for me to do it like that. And in the blue window, I've got they're all in the Crowbar directory. But for this one is where I usually like to run the web server in the window. So I have my dev system right now, and I've done a normal setup of all the regular things. This is, yes.
The checkout tree.
I've run dev setup like I normally would to do a builder, and I can do a dev from here. I can do a dev build ISO. So if I wanted, I could do a dev fetch and pull in the latest code. The normal, I don't want to. You already know dev tools. So I'm not trying to teach dev tools. But there are some extensions in DevTool that are different. That's what we're going to talk about. So if you look at the help for DevTool, which I can do over here in this window, dev help, you'll see there's tons of commands in here. What we're talking about here is dev tests section. So in the dev test section, there's a whole bunch of commands that don't exist in Crowbar 1 at all. They're completely new function in Crowbar 2.
I have seen those.
Good.
I've run them. I've seen them.
My dev fetch is going to fail because I don't have my proxy set up on this window. I have it in a different window. That's one of the funny things about using these sessions is that I don't automatically configure my proxy. I set it up in the Windows, but on a Dell, and if I work equally outside of Dell, it doesn't pay me to pre-configure the proxy.
That's in the environment which is running Ubuntu.
So in this case, I've got my dev environment, and the first thing I'm going to do in this case, because I've been working in the environment, is I'm going to do a dev tests clear. And dev test clear is pretty straightforward. It removes the environment. If I wanted to, I can do a dev test setup, which is going to go through and now set up my test environment. What that is doing behind the scenes is it's going into temp and it's building a directory, Crowbar dev test, and it's literally doing an install of Crowbar to that directory. So it pretty much it's a little bit specialized, but it installs Crowbar to the temp directory. So what you'll see is there's an opt-del directory, and inside that opt-del directory, you can't read it again. The purple on the highlights. Let's see if that makes it easy.
Earlier today, you asked about the Ruby version.
Mm-hmm.
We need 1.9.
Yes.
Do we use just the distributed version? Because I've been doing regular gem updates so that I have the latest gem files.
You'll want them, but part of the reason we're doing an install over here is because it brings in the gems from the cache. So when you do a Crowbar install and when you do a dev test install, this is really important. We actually use the bits from the cache, from the Crowbar cache, not from your local. Sometimes it's from your local. There's a little bit of a warning.
So in terms of my dev environment, should I strip out my Ruby and have a vanilla Ruby?
You don't have to. No. It'll pull the appropriate bits. and there's a setting in here. I haven't had to do this in a while because I've been set up. But the first time, you probably want to run update gem gems cache like that, and this will actually go through and do. I typed it wrong. Let's see. Here's my setting. Here's my options. Help debug, no install, deploy, base. Oh, it's part of my install. Let's see. Dev tests help. And there is a no gem cache and an update gem cache option here. And that will effectively force your cache to get corrected. But every time you do a clear, it deletes the temp directory.
That's the actual gem files themselves, not the installation of the gems into the Ruby that you're ready to run.
It puts them in a place where bundler. So one of the things about Rails 3, right? Crowbar 2 uses Rails 2. Crowbar 1 uses Rails 2. Crowbar 2 uses Rails 3. And that lets us take advantage of bundler, which controls the gem collection much, much better. And so, and that's one of the things you'll see is if you ever want to run, and I'll show you how to do this, if you want to run it from the test environment directly, then you need to tell bundler to start it. Bundler points you to the right repos, right gem caches. So, but we're definitely using Ruby 1.9, and we're using Rails. Actually, it doesn't really matter what Rails I think I'm using here, because I'm actually using the one from bundler, which would be different. But it's very important that you do all this work with Ruby 1.9 as default. Right. Good. So
I've been doing all my work with Ruby 1.9 since when I started.
Which is right. You should. You really want to be 1.9. But Crowbar 1 installs and uses 1.8.
Yes.
Under the code.
1.8.
Even though the dev environment will not. So here, the thing I've done this dev setup. What I originally dev tests was all about this dev tests run command, which is going to take a little while to run. If you haven't done setup, running dev tests run or dev tests, some of the other commands will automatically run setup. So you don't have to run setup and then do the next step. Setup will include it. In this case, setup sets some things up, and then run is actually kicking in and saying, oh, wait a second, you have to install these other things. As a matter of fact, the tests component for dev is smart enough to know if code in any bar clamp has changed, and every time you run it, it brings in the latest files from whatever bar clamps have been altered. So if you've done a sync, or you've edited the code, or you've done something like that, running the dev tests run or dev test server, which I'm about to show you, will do that. So right now it's going through the process, it's actually doing the migrations, it's building the whole environment. So over here, in this environment, you can go to the Crowbar framework. Sorry, this got reset, so it's not actually. One of the dangers is if you're in this directory and you rerun it, the directory is now not really there. Del. So I can go into the Crowbar framework, and this is the Crowbar web app. So this is exactly what you would see in any Rails app on any installed system, right? In the same directory structure. The thing that's different in Crowbar 2 that you need to be aware of is only the Crowbar bar clamp uses Crowbar framework. The actual bar clamps, like the so I'm going to go into bar clamps, and in bar clamps, in the chef is a good example. In the chef bar clamp, there's actually a Crowbar engine directory. So in Crowbar 2, we split all the bar clamps actually run in linked directories. So there is no, in Crowbar 1 we smashed everything together, right, giant robot smashing together, and we just merged all the code into one place. In Crowbar 2 we use Rails engines, and each bar clamp actually adds an engine into the Crowbar framework and is completely separated. The files never commingle. even though it presents itself as a single app. So I'm going to pause for a second there. In this window, we've completed our database migration, right? So all the code's up. We've run the spec tests.
Sorry, you said database migration. What do you mean by that?
Database migration is how Rails builds the database. So today, we always migrate. You start with a blank database and build it. There is no upgrade path yet. Probably in around the November cutover time, we'll start doing migrations, and then any schema changes would actually be handled incrementally. And what's happening right now is it's doing two things. There's 3 test suites that run in Crowbar. There's a spec test suite, there's a unit test suite, and there's a BDD test suite. Okay. I have a strong preference for BDD because it's really fast, and therefore I've been adding tests at the BDD level because they cover the object models and UIs and APIs, and I get a lot more coverage by using BDD tests. And to save a lot of time.
Just wanted to step you back a little bit.
Yeah.
About the database and schema handling. Have we introduced a method of versioning to make certain that we can do migration across multiple versions?
Yes, Rails does that. It's an inherent feature of Rails. So that's what the database migrations do. But we are not invoking it yet for building that. We expect people until we as a community decide enough, don't stop rebuilding the database. We're going to keep making changes to the root migrations. It's just a pain to manage them. So today we're just assuming people start from a fresh system every time.
Can we move backwards if we need to?
Yes, migrations are bidirectional. So in this case, we passed all the tests, so you can see when it's all these dots, it would say F or E if there was a failure. And then this is the BDD test suite. You can see we're still skipping a fair number of tests. These were all tests that were at one point, most of them were passing, but when we refactored the database in the most recent term, some of the things failed. Part of what I'd like to see us do is the next 2 months decide remove the tests or make them pass. I would suspect most will be removed. So at the end of this, we're going to get a result. I passed all the tests, right? And there were 151 tests in 21 features. And I have a whole video on how BDD works. It's effectively 3 hours of training. It's effectively still the same. My point here is not to show that, but there is a 100% expectation that before you do a pull request, you will be able to pass all the tests using dev tests run. Actually, start at the beginning to make the thing work. Okay, that is part of the contract of doing pull requests is that you must pass all the tests before you do a pull.
All right, so let's see. Where did we leave off? So, we were just talking about BDD, the expectation for pull requests. So a good breaking point. And so what I've got now, and your fundamental question was how to actually run Crowbar.
And it's running now?
It's not. So to run Crowbar, what I want to do is there's a couple ways. The simplest, and this is after doing it the hard way for a long time, we added it to DevTool. So if you do dev test server, I'll show you what it does behind the scenes, but basically it invokes all that, it makes sure there's a working dev system, and then it runs the Rails app. Once I've done that, then I can go in on, so my dev machines, need one. So in VirtualBox, you need 2 VMs, one to bridge out and one to run your local network. So I have this system's configured as 124.3, and so 124.3 3000 is my Crowbar server. So once I'm using dev server, it runs my server.
There's a preset account?
Yes, there's 2 preset accounts. One is Crowbar. And then the other one is dev with Crowbar. I'll show you the password. It's like R0W BAR dollar exclamation point. So there's a developer
Dollar exclamation?
No, just exclamation points, right? Sometimes I use dollar in some passwords for it, and sometimes I use exclamation point.
Is it changeable?
It is changeable. It's in the database migrations. So when it creates the users, it inserts, if you're in dev mode, it inserts the developer account only in dev mode.
Okay.
In production mode, there is no developer backdoor.
It's a backdoor.
It's effectively, yeah, it's an alternate admin account. I would call that a backdoor. Yes. So I can log in as developer, that's created, and then I can use Crowbar in this case, and the whole system's here, but there's no nodes, right? There's the system deployment comes in automatically, but there's no nodes. With Crowbar 2,
so it's under system deployment?
If I click system deployment, I have a base system. And so I could actually come in and add a role, so if I wanted to add the test, and it also only sets up the test jig, because it's a test system. There's no, when you're running the simulator, or when you're running in test mode, there's no chef server to attach to, it's self-contained. So it only sets up, this is work doing, so here's the install jigs. I don't know why it's running slow. So the installed jigs, the script jig is not on, chef jig is not on, only the test jig is on.
Mm-hmm.
In a production system, you get the opposite. You would get, if you installed from the ISO, script and chef jigs, actually the script jig would be active, chef and test would be off. The chef jig is actually configured as a role, and it's not going to turn on until the script jig installs the chef server. So it's really useful to know that there's actually a jigs utility, and we honor these active, inactive flags. There's no way to make them active or inactive. You can click on one and you can see all the roles that it implements. If you go to roles here, this ends up being, now I'm giving a property demo, which I don't want to spend too much time doing, but you need to know the lay of the land. Here's all the roles by jigs. So roles are tied to jigs, so you have to know the jigs.
Okay, let's cover that in detail later. What's under utilities?
Utilities are exported items, so logs, that's not fully wired in yet. Jigs we talked about, and then our old friend bar clamps, which is now much less potent because bar clamps are not the operative thing anymore. They're just containers for roles.
Right.
But this is all the bar clamps that are installed. Users is pretty straightforward. Scaffolds allows you to hack into the database directly, so you can go, if you don't like the pretty screens I build, you can look at these ugly screens that show, basically these are auto-generated based on the data models. So they show, the cool thing about the deployments, and the reason I test them and keep them, is that they will expose relationship issues between objects super fast. So if you break relationship issues, the scaffolds break. So having them in and testing them is really useful. Okay, so you're like, hey Rob, great system, I can't do anything with it, right? Node role is our central thing. There's no nodes, no node roles, we're dead in the water.
Mm-hmm.
Thus, the simulator becomes interesting. So here's what how the simulator works. So the simulator is in the Crowbar bar clamp. So I'm in the Crowbar. Crowbar is Crowbar's dev tool environment. Bar clamps, and then I'm in the Crowbar bar clamp where most of the UI resides. And in this directory is the core of the BDD infrastructure. Every bar clamp can have BDD test suites, but most of them currently reside in the Crowbar bar clamp. We haven't tried to make bar clamps test themselves independent yet. Eventually, it's designed to do that, but we're not there yet. So the BDD infrastructure has a whole bunch of files in it. The first thing, there's a couple things that you need to do, and there's a document in the docs directory. So the other thing to point out is that there's actually a docs directory. Let me start there. So in every bar clamp, there's a docs directory. It's a doc directory, not docs. And it's easy to read this off the website, but it gets pulled into the UI. And there is a dev guide directory, and in the dev guide, there's actually a simulator. I think there's a simulator. Yep, there's a simulator file that explains how to use the simulator. So we, by design, keep documentation in the bar clamps that are relevant for the bar clamps. So one of the reasons we do that is to encourage people to update them when they're actually doing their thing. So let me jump back to the BDD system. So, oops. So in this system, this is basically our Erlang test system. But the consequence of it being our Erlang test system is it also has APIs that actually consumes the Crowbar API because that's what we test. So the simulator is written in Erlang with the BDD infrastructure because that's where the APIs are. So the first thing I would need to do is I need to actually compile all the code. This is done in the test infrastructure. And right now the users, there's some warnings that are getting thrown from tests that are being skipped. If I was in my test infrastructure, let me do that. Temp, Crowbar framework, up, del, BDD.
So where are you in this?
In this case, I'm in the Crowbar bar clamp BDD directory.
Which is the Git repo.
Which is the Git repo, correct.
As opposed to the installed test system.
Right, the temp Crowbar dev test system.
Mm-hmm.
In that case, it's the same code. It's just in the BDD directory, and
there's a copy of that code rather than a link.
Yes, it is copied. So it copies because this directory actually brings together BDD from all of the bar clamps, and it can run them in aggregate. So whenever you run the dev tests setup or dev test run, it actually recompiles the BDD code, and what is happening behind the scenes. And it's important to be aware of this because you can't run the two web servers together. Dev tests run actually kicks up a web server, runs the BDD against a live web server, shows you the results, and then kills that web server. So you cannot run the dev tests server and the dev tests run in parallel because they both try and start a web server on the same port.
Would it make sense to have a separate VM to do this in?
We could, and there's things that we're talking about doing for that. This is surprisingly lightweight, and since we built a test infrastructure that ran a web server,
even if it was a Linux container,
we are looking into doing exactly that. So one of the things we're talking about doing is using Docker to build, instead of installing into a temp directory, to install into a container. Yes, that is something we want to do.
Preempting you to.
Great question. No. So here's what happens. I compiled the Erlang, and then I could almost just run the test from here. What I need to be able to do is there is a default config file that you don't get by default. What you get is a sample config. Or is it config sample? No. Maybe it's config. No. Oh, I must have moved it. Huh. I didn't commit that change. So there's supposed to be a default config file.
How is that?
Oh, here it is. I'm sorry. It's not called sample. It's called example. So the example config file contains the inputs to tell the server how to operate.
And the default config is auto-generated?
No, the first step to use the simulator is you have to copy the example config file, rename it as default, and then rename it. That's in the docs, so it's not that big a step. And then what you want to do is this is where it actually has the password here, CR0WBR exclamation point. So
you can change
you
it.
can change it. This actually tells it what IP address to hit. So this is not right. This one wouldn't work for me because it's not the right IP address. And I've used the BDD. One of the nice things about BDD is you can run it against any system. So I can run it from my machine and I could hit localhost, or I could hit the test ones use localhost. I could use a VM. I could put it against a Docker with a different IP address. It doesn't matter. It's just testing the web interface. So you have to check this file and modify it for your configuration. And then once I've done that, I can just run Linux, and I could run simulator like that, and it would run the simulator. I'm going to do a little bit more than that because I want to take another step. I'm going to start Erlang. So ERL starts the Erlang shell. And to run the simulator, I just need to do dev pop, populate, like that. That tells the simulator is very simple. It only says dev pop or dev unpop. So it populates or unpopulates. It does it from a file. There's actually, I'll show you the file before I do that. So to get out of the Erlang shell, it's Control G and then Q. I don't know why they didn't make it. I know why they didn't make it exit. But, and there's a file called dev.config that has a list of the nodes that you're going to create, the attributes you're going to do, the groups that you want, the deployments. So there's actually a fair bit of information that comes from, it's configurable. So if you wanted to do a 100-node system and didn't want to write Erlang, which would be also a way to do it, you could just add 100 nodes to this file and it would create a 100-node system. And it populates them in racks, and it's not much code, but it does a fair bit of stuff to get you bootstrapped. So going back to the Erlang system, if I do dev pop, open close parentheses like that, it actually goes to the website and invokes all the API commands necessary to bring up a 5-node system. And then, because the refreshes are working in the tool, it actually shows them. So yeah, so you saw in this case, I ran dev pop, I created the system. I could actually do a dev unpop, and it's going to remove them all. And you'll see that in the next. It takes a while. So, and I've been working to try and make it so that you can run the dev test system and the dev simulator side by side. So I'll show you how I run unit tests from here also, because that's really, really helpful to know. But this, now I've created nodes. And so these nodes, the way Crowbar works is any new node that's discovered, meaning that it's added to Crowbar's database through the node API, automatically is added to the system. It's automatically added to the system deployment. The expectation is it only would get added. Nodes always come into system deployment. It's the only thing that you can mess with in system deployment is the node discovery process. But we're still figuring out the right rules for that. So we haven't cranked down on it. So I can now come in and start navigating the system. This is the deployment. This is the snapshot. So the current snapshot for the system deployment is called system. And then you can see this node is in the to-do state. These nodes are in the block state, because that's the tree between test admin and test discovery, as a matter of fact. If I play with my fancy graph, you can see this guy is in the middle of all these other nodes. My latest was a cool feature. So from here, what I can do is go in and I can anneal that. So this annealing screen is for that snapshot. So it's specific to the snapshot. And what it's doing is it's going through and it's saying, all right, this is blocked. He's actually now got picked up by the test system. He's transitioning it. But the test jig has built-in delays. It's just arbitrarily, it pauses a couple of seconds to let you watch the system operate. Otherwise, it would just be done. It wouldn't be exciting. So in this case, what's happened is we've annealed one pass, and we've completed some work. So now there's a whole bunch of nodes that are in the to-do state and none in the block state. The dev tool, I'm about to add a converge button that just keeps running. The Victor is exposed, but not in the UI. And So by the time people look at this, there'll be a converge button right here, and they can just run all this in one step. Annealer is designed to step you through this one thing at a time so you can watch it. So I hit anneal again. If I actually hit it, I don't think I did. I didn't. And what it does is it goes through, it marks everything from to do. It's gonna take it and start transitioning those nodes, which is exactly what happened. So these now are all transitioning through the jig infrastructure. And if I look in the logs, I can see a whole bunch of stuff. As a matter of fact, I can click this guy. Oops, he's moving. Right, if I click on that, it's going to show me the, this is the node role information. This one has an overlay, so I have the pretty form instead of the text box to edit. And I could turn off the delay or change the delay time or change the log marking information. It's all pretty straightforward, and I can see everything, including log captures, right? We're trying to make the test jigs able to test all of the capabilities of Crowbar, so they do everything that regular
So this is purely for development purposes.
Development and test. Mm-hmm. So if you're having a behavior issue in Chef, you should be able to isolate, if it's Crowbar behavior, you should be able to isolate it in Crowbar, create a test for it, make sure that see how the test breaks, and then fix it, pass the test, and then go back to Chef. Right? We want to make sure that the logic within Crowbar operates completely self-contained. And we've been actually pretty rigorous about trying to make sure that happens. I'm really excited about a lot of this stuff. I feel like we've really raised the bar for this. Just this type of infrastructure that lets somebody play with Crowbar and operate it and anneal it and do all this stuff without needing Chef is a huge deal. Right? Mm-hmm. So in this case, I've gotten to a point I can create a new proposal. In this case, I now have a proposal. It shows all of these node roles are now proposed. So if I go back to the deployment, this is the deployment. I can see my history and so there was stuff going on every time I was adding new nodes. It was taking it through a proposal system. Yeah. And in this case, I can add new, this is how you add new events, or add new roles into the system, and to use that role, you just drag the appropriate node in, and sometimes it's hard to see this, so I need to look at icons, but it's actually adding the node roles here. So if I wanted to take node 2 and make it part of the test library, if I click here, I can now edit. I haven't done an overlay on this one, but I can drop this from a 5-second delay to a 2-second delay. If I save it, sorry, it doesn't save it here. I have to do this. This is a little confusing. This is what's going to be sent to the jig. This is the actual data in the system, and so I haven't built overlays for everything yet. But this is what the overlay hides, is having to do this. So in this case, what I did was I changed the JSON to say, you know what, I want to override delay 2, and now it's changed the default version. I'll show you where that is, from delay 5 to 2. So if I go back up to the role here, you'd actually see, I can't edit this yet. This is the default, and I overrode that default for that one node role. That's core how this operates. So now if I go back to my deployment, here's my active foo. Here's, once again, this is the node role screen. And if I commit this, now we're back to these guys can all operate. They're not blocked. And these guys are blocked because they're dependent on the test.
So if you anneal this now?
It's going to run through the process. Happy as a clam. Assuming I actually clicked the button, which I thought I did. No, I didn't. And you can run the annealer multiple times. But this is actually running as a background thread, so it's parallel. Matter of fact, one of the things that I know Victor does is he goes to the annealer. Oops, it's just anneal. Yeah. I don't know why it's not actually, it didn't actually take my anneal.
What's the significance of the 20 there?
20 where? Oh, this is the snapshot ID. So foo is snapshot. I could have easily put in, snapshots are a little weird because they're not, you can have the same name for multiple deployments, so you couldn't just put foo in here, although it would try. pretty hard to do that. Some things like deployments are uniquely name scoped, and so you can, the premise we've had, so if I had deployments, I could say system, and it would take me to the system deployment. Cool. We've tried as much as possible for the API to allow you to use names when there are natural keys. And this is cool, you're actually getting live updates about the status of this deployment. So I can go and anneal this guy, and he's annealing in the background. And so in this deployment, these things, actually assigned roles, are actually going to change. And you'll remember from when we built the state machine, there's things you can do when you're proposed, but you can't do when you're committed and all those things. So these states matter, and then one of the interesting things here is these nodes their node roles are all into active. These guys have partial state, and as the annealer kicks in, they'll transition. I think for some reason my annealer is not. No, it's doing its thing. So these nodes are going to automatically, they're already there, transition, and they only transition, their state changes based strictly on their node role state. And so in this case, I can see all my node roles, which deployments they're in, there's a ton of information here. We're still trying to figure out the best way to present it all. That's why you want a simulator, so I can create a 100-node system, and somebody can say, oh, let's see how the UI performs with 100 nodes. And there's nobody in the lab going, oh, I can't find 100 nodes! Or however accent they would say it.
Okay. How fast do you expect this to, I'll rephrase that. What is the anticipated delay on physical hardware machines?
As soon as, it should work right out of the box, right? As soon as we have discovery today, it should actually be able to discover.
No, I mean the annealing delays.
It's Chef, so Chef is going to, whatever it takes Chef time to do that. So there'll be a fair bit of latency. So I know when Victor's playing in the...
that should be a lot faster with Chef 11, shouldn't it?
It should be, but what's cool is there's a lot more roles, but you're going to see when Victor does the demos, right, he has one node and 20 roles as opposed to 20 nodes like I do. But you can actually watch it make like literally a line chart. It moves through this and shows each node changing. And then the thing that's amazing is every one of these node roles captures a log. So as it's making progress with Chef, it actually brings back the Chef logs, all the relevant logs, and puts it in the node roll so you can look and see what happens. So if there's an error, so John, let me show you what happens if there's an error. So you say, no, it's a simulator. Can we actually make sure things fail? Well, we can. There is a failure role for the test jig that always fails. And so I can commit a failed role, and then I can anneal it, and it will force the system into a fail mode, and I can see what happens when it fails.
So this is something we'll be able to use for diagnostic purposes in a real live environment as well.
Yeah, we could.
Cool.
So we're going through the thing. We have the fail jig, so it's going to come through and it's going to give us a fail result. Aha! So we got the red fail light, failed. These are all still to do. Can't proceed. Now a failed roll, and in this case we see it's error, and it actually tells us, there's no log right now for this. But one of the things I need to do is actually make a true false in here that would allow you to succeed. And so there's a retry button, and so I can tell it retry. It moves the state back to do, and then the annealer, when the annealer comes in and works, is going to try again. And so if I could,
and it'll fail again, or
it'll keep failing. Right now there's no way to recommit. So what we're still working on the pattern by which you could change the settings. Right now, it's a retry option. It's not a reconfigure. So if I don't like this, I could take that snapshot that failed, create a proposal from it, and then edit it, and then fix it. And one of the fun things about having all this is that we can literally play with these scenarios in test, see if they work, if they make sense, play with it, all that stuff. So simulator is really important. This ends up being, here's the simulator and here's the test jig, because they are tightly coupled. They don't make sense without one without the other. Keep doing that.
This is planned failure.
Planned failure. So that's a lot of what, right, showing this is the type of thing where you can sit down.
May I for a second?
Please.
When you bring that up, it brings up another, oh, I see.
There's extra menu items, and there's some of them that are default.
I see. Okay.
So, but what we just walked through is enough that you could actually sit down with nothing but a dev machine, crank up Crowbar as a server, create nodes, play with the annealer, check the annealer. You could actually, edit code and do things like that. Now,
so we can actually do a live edit, test it, and when you're happy, just do a commit.
Correct. So what I do when I'm actually editing. So everybody right now has a different style. We need to start converging. Because I use Windows, my code runs. I use Sublime. I really like it. I have a Samba share mount through to my VM, and I can check out. This is the Crowbar.
Are you running VI here?
This is Sublime. But yeah, and so I can edit the code on the VM.
Are we going to invest in having the same IDE/edit/dev environment?
We're working to converge it to a much smaller subset. And what I actually is a little script that I use to basically it installs a file hook. There's a couple different ways to do this. It installs a file hook, and then this file hook will synchronize against the running dev server. So when I do this, if I make an edit over here, it's going to copy it into the dev directory for Crowbar.
Sublime does that automatically.
Sublime doesn't. I have a script that does an rsync.
Okay.
It does a file detect and then an rsync.
Using FAM?
It doesn't use FAM. It uses iNotify.
Sorry, which?
iNotify. I'll make the script available.
Okay.
All right. Got this. So that would allow me to synchronize the changes. The thing to keep in mind is that if you're doing this for a bar clamp's files come from the bar clamp Crowbar engine directories, not the Crowbar framework directory. So the biggest thing to keep in mind if you're working in a bar clamp is if you're going to play this game with synchronization, which the dev server picks up just fine.
So where should we be editing? In the Git checkout?
Yes.
Not in the test environment?
Do not edit in that temp directory. Edit,
so do we have a mechanism for automating the process of copying edited files across into the test environment?
Yes. So if you just stop and start the server, like this, it will automatically sweep and see if there are changes and copy them.
Okay.
I'm too lazy for that. I like it to be faster. And so I push the changes. I synchronize them. And we need to document that process or figure out a standard way to do it.
I hope I'm asking the right questions here.
They're great questions. That's part of people need to understand how to synchronize their dev environments. The challenge is people do it differently, so for some people they'd like one way, or some people the other.
I wished I were consistent.
I'm not consistent, that's right. I'm not consistent either. So,
consistency is a good thing. It kills creativity, though.
There's times for different ways to do things. I know Adam has like a synchronization he does, and Judd has one, and I have no idea what Victor does. I can't keep up with his keystrokes to figure it out. And he uses a totally different dev process. Like, he doesn't run the simulator; he just deploys live. So we all have slightly different nuances about how we work and what we're delivering. I like this because it's a great way to bootstrap and just to get to know your way around and practice navigating without a lot of overhead. One thing that I'd be remiss to skip.
Sorry, pardon my interrupting. At this point, we're working off a single dev VM.
Correct. I only have one dev.
So that could be a physical machine for all intents.
Sure, you could run this if you had a desktop, Linux desktop that ran the dev tool. You could do all this stuff against the Linux desktop just fine. Yeah, completely. The only reason I do it like this is because I've got a Windows corporate Windows image. So one or two last things to show you before we wrap it up. So I showed you the simulator here. The other thing I run a lot from here is I use the BDD environment. So to run the BDD environment, I just run BDD test, BDD:test, open and close parentheses. And what you'll see going on here is it's literally running the web server. So in this case, tests are running over here, and the web server is going crazy over there. The reason I do this is when I have a test that fails, I'll show you exactly what I do. Because this is running all the tests. If it fails, I'm not going to diagnose from this screen. It's doing everything. But we had a test that failed. Good. So I can show this. And since the last time I was showing BDD, I've actually improved the performance even more. I still have not parallelized it, and so all these tests could actually run in parallel. So here's what's going on. I've got this node, and I think I caused this failure. But what would happen is, if I wanted to look at one test, I could debug, or one feature set, I could run debug node, which is going to run just that one scenario set, that one feature. So in this case, there must have been a timing glitch. It passed it, or there was leftover crud from playing in the simulator, which is why I should have done an unpop first. Sometimes I bother. I try to make the tests in the simulator and the not interact, but there's only so much I can do. Sometimes they interact. So in this case, it's now passed all the tests when I ran just that one scenario. There's a lot of documentation for these commands. I can also, if I want a lot more description, I can run a BDD debug node, it's the name of the node, and I can pick one of these tests, like that one. And so if I pick an individual test, each one has a unique ID, then I'm going to get data back. I'm going to get a lot more data to see what happened. And so over time, we have made a lot of debug data back, or a lot of debug information come back. So in this case, you'll find that if you run debug on a failed test, a lot of times you can see exactly what happened. In this case, the JSON API returned a non-JSON result. It couldn't find it, and so we know what's going on. But this is actually the expected result, because it's expecting to get a 404 error. So the scenario is that it's expecting a 404 error, and so that's actually a passing test when it doesn't find it. And then it comes in and does all this stuff. I've been slowly, there's a huge test. I've been slowly building towards being able to test all the annealer function, and I've been having to expose a whole bunch of functionality as I go. So I'm sort of working towards tests that actually test the full anneal cycles. And the fail cycle, and the event cycle, and on and on and on. So I try, my goal sort of is to add like a test a day. More, if I'm writing active code, I try and test it. I write the test before I write the code, but for the annealer, I'm catching up, and I'm slowly doing things.
Okay.
Any other questions about the?
Nope.
Cool. And I don't know why. Here's my pretty UI.
Got a failed node still.
Let's stay that way.
Stubborn node.
Cool.
Okay, we're done recording.
Good. Thank you. It was good. Good question.